Welcome to section 3.4, substitution, not antiderivatives of formulas. That was the previous section. We're going to do some practice, talk about a new way to find some antiderivatives. And if you're tired today, that's okay. I'm tired too, but we're going to get through it together. What better way to gain energy than doing a little calculus? So let's see what we got here. Example 0, evaluate this derivative here. So let's see how well you remember chapter 2. To evaluate this derivative, okay, constant multiple rule says this constant comes out in front. We don't have to worry about the 1/4. So we have 1/4 times the derivative of this guy. Oh, we need to use the chain rule. So u can be the inside function here. And then again, we have f prime of u times u prime. That's our chain rule. And u is x squared plus 5. F of u is u to the 4th. Okay, hopefully this chain rule should be pretty comfortable by now. So when we take f prime, we get 4u cubed times u prime, which is 2x. We get a little cancellation, 4 times 1/4, great. We're left with 2x times u cubed. And remember, u was x squared plus 5. That was the chain rule. Ta-da! We did it. That's the derivative. That's chapter 2. That's the chain rule. Now, what does this have to do with chapter 3? Well, again, likewise, we could look at this integral over here for b, and it should look a little familiar. The integrand should look familiar. Oh. Integrals are antiderivatives. So if we know that the derivative of this guy is that, well then likewise the antiderivative of that is this guy. So we just know that this is 1/4 times x squared plus 5 to the 4th plus c. That's the whole idea of an antiderivative. The derivative takes us down here. The antiderivative takes us back, right? So how can we formalize this process? We have the chain rule to take the derivative of something like that. Well, we have something new to evaluate integrals that look like this. And that's called the substitution rule. It's not the substitution rule, it's just called substitution. And substitution undoes the chain rule. So what we're going to do in this section is introduce how to anti-differentiate, how to take the integral of functions that look like this. Functions that are kind of the result of a chain rule. Because again, remember the whole idea of an antiderivative is we're undoing derivatives. We're going backwards from derivatives. So let's approach it very similarly to how we approach the derivative. So the question is, what happens if we do this substitution? If we let u be equal to that? Well, that means we're going to get the integral of, let's keep the 2x for now. I don't know what that's going to do. And then, okay, u is x squared plus 5. So we have u cubed. And then we have a dx, which isn't so great. So we can't take this integral because we have x's and u's. We need everything to have the same variable, right? This says we are taking the derivative with respect to x. So having a u here is a big problem. These should always match. So, okay, so we did a substitution. That's good. It makes it look a little better, but we need to get everything in the same variable. Well, just like we had with our chain rule, the chain rule said we also had to look at u prime. Well, let's do the same thing over here. Remember that u prime is du dx. That's what u prime means. What is du dx? It's 2x. So watch this. Are you ready? 2x is du dx. So if 2x is du dx, let's replace it. They're the same thing, du dx and 2x, same thing. Just plug it in. And now we have something really nice. Because even though this is a derivative, this is not a fraction. But the way that derivatives work is pretty consistent in a lot of ways with how fractions work. So we really do have, get it? So we really do have that this is u cubed times du. Again, technically these aren't fractions, but they do cancel out in this way. The behind the scenes of calculus. So again, we know how to take this antiderivative. We add a power and divide by that power and add c. And our final answer is what is u? Dividing by a quarter is the same as multiplying by 1/4. U, we said, was x squared plus 5. And lo and behold, you've done your first substitution. Figured out how could we evaluate this antiderivative if we didn't already know it. That's what we're doing here. It's just a chain rule, but backwards. We substitute an inside function, look at a derivative, get everything in terms of u, and integrate. So if you want a step-by-step process, here it is. Again, we're undoing the chain rule. So we have something like this, something that looks like it would have something to do with a chain rule. A function inside of a function, often, not always. We're trying to get everything in terms of u. And then usually we let u be some part of the integrand, just like we did. Oftentimes this is an inside function. And then we do these following steps. Let's introduce these steps a little bit more in the next video. You've seen it here. This is a good introduction. We'll go through these steps one by one when we actually look at some problems in 3.4.2. All right? Take it easy and have a good one.